Welcome back everyone. Today we have another video on web fundamentals, putting it all together, and in today's video we'll learn how all individual components of a website work together to bring you access to your favorite website. So let's get started. Moving to task 1, putting it all together. From the previous module, you'll have learned that quite a lot of things goes behind the scenes when you request a web page in your browser, ideally DNS, HTTP, all of these stuff. To summarize, when you request a website, your computer needs to know the server's IP address it needs to talk to, and for this we use DNS. Your computer then talks to the web server using a special set of commands that's called HTTP protocol. The web server then returns the HTML, JavaScript, CSS, images, etc. that's needed to render the web page, which your browser then uses to correctly format and display the website to you. There are also a few other components that help the web server run more efficiently and provide extra features that we will get into. Let's join the room. Let's hit the complete and let's start with task 2. Other components, starting with load balancer. When a website's traffic starts getting quite large or is running an application that needs to have high availability, let's say a banking application or a website, one web server may not longer do the job because of the sheer ton of requests, or let's say someone's trying to take it down by sending a lot of requests. So load balancers come in handy. They provide two main features: ensuring high traffic websites can handle the load, and provide failover if a web server becomes unresponsive. As you can see here, we have 3 servers as an example, and this is your browser as a client trying to reach that server. Let's say try hack me. So let's continue. When you request a website with the load balancer, the load balancer will receive your request first and then forward it to one of the multiple servers behind it. So it doesn't just send your request immediately to the server of try hack me. It reaches a load balancer where it stops, and then the load balancer will decide to which server of try hack me it should send it to. And this is based on some protocols or algorithms, and these algorithms decide which server is the best to deal with the request. Couple examples of these algorithms are round robin, which send it to each server in a turn, or weighted, which checks how many requests a server is currently dealing with and then decides which the least server that it should send it to. Furthermore, load balancers also perform periodic checks with each server to ensure that they are running correctly, and this is called the health check. If a server doesn't respond appropriately or doesn't respond at all, then the load balancer will stop sending traffic to it until it comes back and responds appropriately. So the load balancer comes in handy for large web servers and large websites, so it can load the balance between each server, so no one server gets shut down by all of these traffic. Another component is CDN, or what's called content delivery networks. A CDN can be an excellent resource for cutting down traffic to a busy website. It allows you to host static files from your website, such as JavaScript files, CSS styling, images, videos, and more, and host them across thousands of servers all over the world. And these servers doesn't have to be under your domain or anything. So when a user requests one of the hosted files, let's say from try hack me, and you're requesting some JavaScript files, the CDN works out where is the nearest server physically located next to you, and send the request there instead of potentially to the other side of the world. So instead of you sending it to try hack me, which is on the other side of the world for you, it will send it to the nearest CDN server that will retrieve these files for you. Our next component is a database. Often websites will use a way of storing information for their users. A web server can communicate with a database to store and recall data from them. It can store user information, credentials, any other information related to the website, let's say products, etc. All of these stuff. Database can range from just a simple plain text file up to a complex cluster of multiple servers, providing speed and resilience as well. You'll come across some common databases: MySQL, MS SQL or Microsoft SQL, MongoDB, Postgres, and many more, and each with its specific features. Each can have different syntax when it comes to trying to write to that database in a language that's called SQL, and some of them even have a different type of language that's called NoSQL, and we'll get to that in further modules. Our last component is a WAF, Web Application Firewall. We can click here to see what's a firewall. A firewall is a security tool, hardware or software, or can be both. This is used to filter network traffic by stopping unauthorized incoming and outgoing traffic. So basically we have a firewall that stops unwanted traffic, and we can have it in the web application layer. So it's called WAF. A WAF sits between your web request and the web server, just like the load balancer. Its primary purpose is to protect the web server from hacking or denial of service attacks. It analyzes the web request for common attack techniques, whether the request is from real browser rather than a bot. It also checks if an excessive amount of web requests are being sent by utilizing something called rate limiting. So it rate limits one IP address into sending, let's say, 3 requests per second. If more, it will start dropping these requests and never send it to the server, which will only allow certain amount of requests from 1 IP per second. If a request is deemed a potential attack, it will be dropped and never sent to the web server. So we have 2 components that sits between our browser and the web server. The first is WAF, and followed by the load balancer. Let's start with the questions. What can be used to host static files and speed up client visit to a website? That should be the CDN. Next, what does the load balancer perform to make sure a host is still alive? That should be the health check that it does. And finally, what can be used to help against hacking of a website? That should be the web application firewall, or the WAF. Let's move to the next task. How the web servers work. So what's a web server? A web server is a software that listens for incoming connection and then utilizes HTTP protocol to deliver web content to its client. The most common web server software you will come across is Apache, Nginx, IIS, and Node.js. A web server delivers files from what's called its root directory, and we will get into that, which is defined in the software settings. For example, Nginx and Apache share the same default location of /var/www/html, and this is in Linux operating systems. On the other hand, IIS uses the C and then int pub and then /www root, which is for Windows operating systems. So for example, if you requested the file hosted on www.example.com/picture.jpg, and let's say you requested it on a server that deals with Linux operating system, you will have the Linux operating system path, which is this, and then starting with your image, and this is from its local hard drive of the server itself. Moving forward, we have virtual hosts. Web servers can host multiple websites with different domain names. To achieve this, they use virtual host. The web server software checks the host name being requested from the HTTP headers and matches it against its virtual host. So the virtual hosts are just text-based configuration files that the server have, and then it checks the host header on every incoming HTTP request. If it finds it, let's say tryhackme.com, it will send it to tryhackme server or website within its server. If it finds a match, then the correct website will be provided. If no match, then it will send the default website. Virtual hosts can have their root directory mapped to a different location on the hard drive, so it doesn't follow the normal format. For example, 1.com being mapped to /var/www/website1. You don't see HTML here. And 2.com following the same format. There is no limit to the number of different websites you can host on a web server. As long as the web server can handle them, then you're welcome to have more. So let's move. Static versus dynamic content. Static content, as the name suggested, is just content that never changes. Common example are pictures, JavaScript files, CSS files, etc. But you can also include some HTML tags that will never change, just like the header tags and some of the body elements that will never change. Furthermore, there are files that are directly served from the web server with no change made to them. On the other hand, we have a dynamic content that could change with different requests. Take for example a blog. On the homepage of a blog, it will show you the latest entries. If an entry is created, the homepage is then updated with the latest entry. On the second example might be a search page or on a blog. Depending on what word you search, different results will be displayed to you. These changes to what you end up seeing are done in what is called in the backend. So all of these changes are being done on the server side. He changes the stuff and then send it back to you as a client. With the use of programming and scripting languages, It's called the backend because what's being done is all done behind the scenes, and you as a client, you can never see what's on the backend, or shouldn't. You can't view the website's HTML source code and see what's happening in the backend. While the HTML is the result of processing from the backend, everything you see in your browser is called the frontend, including the source code that you can navigate into. Scripting and backend languages, there's not much limit to what a backend language can achieve, and they are what makes the website interactive to the user. Some example of these languages, and it's not in any particular order, you have PHP, Python, Ruby, Node.js, and Perl, and you have many more. These languages can interact with the databases, call external services, process data from the user, so on and so forth. They can do a lot. Very basic PHP example of this would be if you request a website. So let's look at the example. We're requesting the website example.com, and we're navigating to the main page, which is called index.php in this case, and we're giving it a parameter in the URL. And how you give it a parameters by starting with the question mark, as we said before, and then our parameter with the name and its value is Adam. So how will it be processed in the backend? In the backend we have the word hello, which is static, it doesn't change, but the word name can change based on what the user enters, and in this case the user enters Adam, so echo will just print out what the user entered or what comes after it, and in this case it will be the name, so whatever the user enters as the name will be echoed out or printed, and we will look at the output, and the output will look like something like this. So we have our hello, which was static, and the word Adam can change based on what the user can enter. You will notice that the client doesn't see any PHP code on the back because it's in the backend, and this interactivity opens up a lot more security issues for web applications that hasn't been created securely, and this happens a lot when it comes to codes or like web pages that were created long time ago and now they're not secure and need to adapt to modern security, as you will learn in future modules. So now let's go to the questions. What does a web server software use to host multiple sites? That was virtual hosts. What is the name for the type of content that can change? That should be dynamic, and remember the other type is static. Does the client see the backend code? It should be nay. Sometimes the backend code gets leaks by mistake. So now let's go to the quiz. Click on the view site button on the right. Use everything you've learned from the other modules. Drag and drop the tiles into the correct order for our request to a website works to reveal the flag. We have a note. When placing a tile in the correct position, it will highlight green. When a tile is in the wrong spot, it will highlight red. Make sure not to refresh the page as it will reset everything. Let's click done. So basically, from what we've studied before about HTTP protocol, DNS protocol, we need now to place them in the correct order. So starting with the request should be the first thing to do. And now let's look at the other tiles. So starting now with the DNS protocol, to know the IP address of tryhackme.com, remember the three cases. You start with your local cache. If not, you go to the recursive DNS server that you have. If not, it will go to the root server, which will lead you to the authoritative server, and then you can connect. So this is the local cache. We can put it in the second place. And then where is the recursive? Here we go, the recursive. And the recursive, if it's not there, it will lead you to the root. Bear in mind that you don't need all of these steps. It highly depends on what's your case. And the root will guide you through the authoritative server. Once you reach there, you need to connect to the web server. But as we talk in this chapter, on this module, we have two more components, which is the load balancer and the firewall. And the firewall will be the first to interact with the request. If it has any malicious attempt to attack, it will deny it. If it passes through the firewall, it will go to the load balancer, and then the load balancer will check which server should it go to. Once that happens, you should connect to the web server at that point, and the web server should receive your request. And now it can or cannot, it depends. If it wants to check its database, let's say you want to send a message or authenticate yourself, then it needs to talk to the database to check your credentials. And finally, you will receive your response and your browser will render it. And as you can see here, we finished it. We copy the whole thing, THM, you got the order and submit the last flag, and that's it for this lab.